There you go. It's all yours.
Thank you. So yeah, welcome everyone, and it's almost night here, so good evening. So I also wrote on my description that if you can carry some cucumber and knife or something, then we can have this little interactive session. This is vegetable math. By the way, my name is Nihal Pandya. I mostly work with activity-based education. This is actually my lab, my our center, and many activity based things that we keep developing. Vegetable math is something which I really like, since it's pretty much household things that we can use, and through that we can make maths very interesting. One of the part in maths in even in our state, in our CBSE national board, there is a something called 3D visualization, right? And many a time things are only in textbook, so it's only two dimensional. So even if it's 3D visualization, there are no objects, specific objects that people, teachers have in classroom. So I would just take a moment. If possible, you guys can switch on your camera. It will film a little better. And also, does anybody have that vegetable or knife with them? I'm waiting for response for a while. Am I audible? Hello.
Yeah, we've got you. Yeah.
Yeah. Okay. Fine. So,
You might need to demo. Have you got a vegetable and a knife?
oh yeah, I have. I was hoping to have little interactive session, so I was just waiting if anybody have and want to join with that, join in that interaction. But I believe nobody has. So, anyways, yeah. So basically, yeah. So in textbooks, many of the, even if it's called 3D visualization, still there are no 3D objects that people bring into classroom. So here, let's say I have this cucumber, right? Now let me start with a small story. Let's say a king has a lot of treasure, and for that treasure he want to make a chest and lock for that chest, and he calls some of the genius engineers of his the one basically, and somebody come up with a option that let's make two holes, like, so I have these thing, right? So we'll little bit discuss on this. So that engineer says that, okay, I'm going to make that key in such a way that there will be two holes, one is circle and another one is square. Okay. Now, if that key, that one single piece should pass completely through circle, and that should also pass completely through square. When it passes through circle, it should touch all the side, and if it passes through square, it should touch all the sides of this square also. Okay, the square hole. So, the answer to that would be in a cylinder. Let's say if this is cylinder, so if we cut cucumber, so cucumber is cylinder. If we cut from both side, then if we look from this side, as you can see, this is square, right? It will be square when the diameter and height matches each other. So, and when we look from this side, it's circle. Okay. So this will pass completely through this shape, circle, and this will also pass completely through this shape, which is square. Okay. So that way, this will also, when it passes through completely, this will touch all the side of this square, and also this will touch all the side of this circle. So comparatively, this is very easy, right? Easy key for that pressure. So obviously, let's, the engineer now need to make it little complicated. So the next challenge is that let's make it you know, 3. Also add in triangle. So now, if we want to convert these into from any one side, if we look at this, then this should look like triangle also. So it should look like circle plus square plus triangle, right? Then what could be the answer? Then what else can we do in this? So the triangle is also added. So again, I mean, this is integration of little story into that, maths teaching. So once more, if anybody has vegetable and knife with them, then they can try that right now, and we can give 1 or 2 minutes, or I can carry on. Okay, looks like I will carry on. So let's say if I cut this into like this from one side and from another side like this, right? So now this gives me a triangle. So now this can pass through this triangle also completely. And obviously in this triangle and also in square, so let's say from this side, it will look completely square. From this side, it will look complete circle. And from this side, it's triangle. Okay. So that is how this object can pass through all these 3 holes while touching all its sides completely. And when we talk about this, I mean, basically the triangle will be exactly here in middle, right? So when we cut exactly from this point, then this is triangle here. This is the perfect triangle. So exactly at this center, when we pass from that hole, then exactly at this center, it would be triangle. Otherwise, not here. Like here, it's not triangle. It's actually polygon. I mean, it's 4-sided polygon, and it will not be completely triangle. Only at this center, it's completely triangle. Same way for square, it will be at this center, right? On this plane, where it will be a complete square from this to this. And for circle, it's the first one. So as soon as this plane gets in, that is the circle, right? So that is how one, basically vegetable you can use. And in addition to that, so we basically do quite many workshops and interactive things with students and teachers. So another challenge we give is from these, we can also make, so there are 5 shapes, right? And we can integrate this 5 shape, any 3 shape out of this 5 shape, and make an object. So let's say here I have made another one. So let's say it's a square, circle, and plus. So I have made this object where it's plus from this side, it's a square from this side, and it's a circle from this side. So yeah. So that is for this one, cucumber, and obviously out of these 5 shapes, we can pretty much basically make 10 combinations, and those 10 different shapes we can make out of this. Okay, let me move on to second one. Another example. By the way, meanwhile here, anybody have any question or anything anybody want to add? I can give it a minute. No. Okay, good. So yes. So the second one is, oh great. Thank you, Sabina. So the second one is I'm using this Mosambik, right? So since Mosambik is sphere, sphere has also very good maths in that. And since again, it's fruit, vegetable, in that you can cut and you can do certain things, on spot in. So it's like So in class, again in class, taking something of these kind of shapes which you can cut easily and which is cost effective, I guess vegetables and fruits are one of the very, reasonable. I mean, you can ask them to bring that in classroom. They can cut, they can do, and then they can eat basically that, same thing. So it's very cost effective and very, yeah, it's a good idea for sure. So one thing in this one, so in sphere, there is another one phenomena, another one thing, which is, so if I take this compass and this one, if I take certain length, right? And if I draw on this top and if I draw on this Mozambique, right? Keeping this length, this is approximately, let's say 3 centimeter or something. So then I get this kind of circle. And now keeping the same length, I am also drawing on flat paper, okay? Which something I have already done before. So if you see here on this paper, I have done that. So this length, this radius, and this one are the same, right? Okay. Now if I cut this one, I mean this, kind of topi, this layer of skin. So I'm just cutting that. Right. So this is that Malta. I did not get Mosambio Santra in this season here. So it's coming up with fruit also, not only the skin. But if I peel out the skin and if I flatten it completely, so right now if you see, this skin is slightly smaller than this circle. Okay. And this is not very, I mean, this might be slightly, flattened spherical, as you can see. But if it is completely spherical, then this would be little less, I mean, little more smaller than this circle here, right? So when we flatten it, so the point is the area of this circle on flat surface and the area of this cap, both will be same. Okay, that is another one very interesting uh, geometry, interesting math there. Another similar to that is, which I will like to show you, is even the cylinder. So let's say there is bottle gourd. Bottle gourd is big enough, which is, could be, the diameter could be same as this, orange or something. So if we take that kind of vegetable and this sphere, then doesn't matter the height. Let's say if we cut 2 centimeter of this sphere and 2 centimeter of the same height in cylinder, and if we check that surface area and sphere surface area, both will be same. Okay. Also in sphere, so another thing is in sphere, if I take, like I have already cut this part, now let me flip this, and let's say I am taking this into, let's say, 2 centimeter height, right? So 2 centimeter from top to here. So let's say if I mark here, and same way I will mark here 2 centimeter, right? So this entire area of this 2 centimeter, so let's say here to here and here to top. So area of this entire cap and area of these 2 centimeter will also be same. Okay. So again, with vegetables or fruits, we can cut and we can check that physically, and so we can do that thing. Now this thing is very interesting for our maps, right? So when we are teaching geography, in geography, this one thing. So let me share my screen. Is it visible? The map? Somebody can answer yes, no?
Yes, it is. Yes, it is.
Yeah, thanks.
Okay.
So in this thing, if you see, it's equator to 23-degree, right? That's the orange area. And from 37-degree to 90-degree. Now, these both, one is orange, highlighted, and one is green highlighted. So the orange highlighted part and the green highlighted part, if you in the sphere, so in our on Earth, if you check the height of both these area, they are same, the way I showed right now, right? So this is basically exactly what I showed right now, that these height and these height, this middle, so 0 to 23-degree and 37-degree to 90-degree, both on sphere the height is same. So basically that says that these area which is green highlighted and this red highlighted are exactly same in map. Yet obviously they look very, very different, right? This green area seems to be very, very big and red area seems to be very small. So let me share another tool online. You might have seen this one, the true size of countries, right? So with that vegetable math, you can explain with this tool. Like here, I checked, and basically the Congo, Democratic Republic of Congo, this size and Greenland size. So Democratic Republic, the equator goes through that, so it's pretty much in center, and it's India. Well, I'm in India, so I was comparing that also, and Greenland. So Greenland looks really, really big, right? And this is DRC, Democratic Republic of Congo. But the size, if you check online, the area of these and this is almost exactly same. And if I take this here, this becomes that big, or the vice versa. If I take Greenland at center, that becomes that small. Okay, so very interesting. I mean, for map, obviously the clarity of size, because many a time we use map not on globe but on flat paper, so it gives very skewed perception of area of different countries. So this is very good and very neat way of looking at things, and also through hands-on things from these vegetables, fruits, etc. So yes, I believe my time is up. Is it? It's
we are at the end of time. Thank you very much for that session.
Great.
It was so clear. Thank you.
Thanks very much.
Thank you. Bye bye.
Take care. Bye bye.